Okay, we'll start with 53. We just finished 52, go to 53. And again, you're looking for things that might help you take the derivative. And I'm going to say maybe factoring might help. Let's take a look. And on bottom, you get 7, and that'd be x plus 3. Looking at top, I see x and x. This is what's known as trial and error factoring. And I see a 6, and I'm going to say 2 and 3. Looks like minus 2 plus 3. Let's just check it. You do get x squared. 3 minus 2 is 1x. That does work out well, and get minus 6. X plus 3 cancels x plus 3. And brief that, x couldn't be minus 3 because it would not be in the domain of the problem. So I'm left off with an equivalent statement, x minus 2. Again, with the understanding that x is not minus 3. What's its derivative? Well, g prime's derivative is quite simple. It's just simply the number 1. I'm sorry, not the number 1. I forgot to put the 7 over here. I just noticed that. It's 1/7. All right? So let's go to the next one. This one over here. And looking at it, what I notice over here is the top and the bottom sure do look alike. I'm going to factor minus 1 out from the top. Get minus 1 times. This would be 3 minus 5x to the 7th. 3 minus 5x to the 7th. Well, again, another conditional cancellation. It's not that number that causes trouble is not doing the problem, so I'm not too worried about that. And what's its derivative? This would be dy dx, or if you prefer y prime, it's just simply 0. All right? So the next one, looking at this, my assumption factoring is going to help out. So 4 comes out, and you get x minus 3. If you look at the bottom, what do you see? Well, I'm going to say an x comes out, and what are you left off with? 3 minus x. Now, someone could say, oh, looks like the same. They're really not the same. They're opposites. So I'm going to factor out a minus 1 from the top. That's minus 4, 3 minus x. On bottom, what do you have? You have x, 3 minus x. Again, a conditional cancellation. Again, that number that causes trouble, 3, is not in the domain of the problem, so I'm not worried about that. And this would just simply be minus 4 over x, which is 4x to the minus 1. The derivative of that, f prime, is going to be 4x to the minus 2, or if you prefer, 4 over x squared. All right? Let's keep going. Let's go to 56. Wow, that looks pretty crazy, doesn't it? This is 5, and you get sine squared plus cosine squared. Well, this is going to be 5 for all real numbers, by the way, and its derivative, f prime, well, the derivative of constant is just going to be 0. Let's keep moving. This one's a little more complicated here, and I'm going to look at it, and wow. I'm looking at that, and it's the cosine squared x minus sine squared x. I kind of recognize that. I want to point out what I mean by that. The cosine of 2x is just cosine squared x minus sine squared x. All right, so let me write this down for you. So it's going to be arc cosine of the cosine of 2x. Okay, so maybe we should start talking about, what the x could be. But I'm going to say for the domain of this over here, that the arc cosine, regardless of what the cosine of 2x is going to be, is going to return the angle that's going to be constant. And so I'm going to say over here, it kind of really depends on what the x is, but I'm not too worried about it over here because this is going to be 2x. All right? However, the x, it's really not just 2x, by the way, but as far as I'm concerned, it is 2x because I'm taking its derivative. And the derivative of 2x is just going to be 2. So let's put this down. G prime is just going to be 2. All right? But again, let me repeat this about the x thing. Like if I had, a number like, I don't know, let's say 4 pi. Or let's just say 2 pi. Or let's just say pi. So it would be cosine of 2 pi, and the cosine of 2 pi is going to be 1, right? So again, let me put this down. If I said x is pi, and cosine of 2 pi is 1, and the arc cosine of 1 would be 0. And it's not the same number, but this doesn't matter to me over here because I'm taking its derivative It's a constant. I'm going to get 2 there. All right? Let's keep going. Let's do number 58 now. 58, we use rules of logs, and this is going to be y equals, this is going to be 5 times the natural log of x, just using a simple rule of logs. What's dy dx? It's going to be 5 times the root of natural log, which is 1 over x. It's going to be 5 over x. All right? Let's keep moving. All right, this one over here, number 59, I get y equals the natural log of 1 minus the natural log of x to the 6. Just using rules of logs, by the way. Natural log of 1 is 0. Then I get minus 6 natural log of x. What's dy dx? It's minus 6. The derivative of natural log is 1 over x, so just say minus 6 over x. All right, let's keep moving. This one over here, number 60, what I would be doing is, again, using rules of logs, it's going to be y equals, it's going to be 1/2 the natural log of x plus 36. It's a very simple rule of logs, by the way. Dy dx would be 1/2. Well, the derivative of that natural log is 1 over its argument. And the derivative of the argument is just 1. So what do you get over here? You get 1, and then you get 2 times the quantity x plus 36. All right? Let's keep moving. This one looks really easy to do. And the root of that y simplifies very nicely. What is simplified is 7x. What's the derivative of that thing, dy dx? Is just 7. Let's keep moving. This one over here, I would break into 2 terms. The natural log of x minus 10 minus the natural log of x plus 10. Let's write the derivative down now, which would be dy dx. What's it going to be equal to? 1 over x minus 10 minus 1 over x plus 10. If you want, you can pull them together, which I'm going to do right now. That would be x minus 10, x plus 10, x plus 10, minus x minus 10. What does that give you? Let's see, x minus x is nothing, 10 minus 10 is 20, and on the bottom you get x squared minus 100. All right? Now granted, the answer that's listed over here is this one over here, but they're equivalent answers. All right? Let's go to the next one, 63. Let me look at 63. I would use rules of exponents now. What's it going to be? E x cubed plus 7x. And the derivative there, dy dx, is going to be x cubed. I'm sorry, I made a mistake there. Is going to be e to the power times the derivative of the power, which is 3x squared plus 7. I want to clean that up a little bit. 3x squared plus 7 times e to the x cubed plus 7x. All right, let's keep moving. This one over here is going to be, let me just keep rewriting it. It's e to the ln, x to the 5th power, and that's just going to be x to the 5th power. So what do you get over here? F prime is going to be 5x to the 4th power. All right, let's keep moving. Over here, I'm going to write it a little bit differently. All right, it's e ln x to the minus 1, and this is just x to the minus 1 now. What's its derivative, f prime? Well, it's going to be minus 1 times x to the minus 2, or minus 1 over x squared. All right, implicit differentiation. A little more difficult, but let's go through it. All right, so I'm going to say 2x. Right, that's the derivative of x squared, by the way. And then we're actually getting dy dx, right? That's what we're looking for. So if you want to write down, you could say, oh, I took the derivative of x with respect to x. We don't normally write that down, but you can. What do you get over here? 2y. We just took the derivative of y with respect to x, which would be 100, 0. So what do you get over here? You get 2x plus 2y dy dx equals 0. I need to solve for dy dx. And what do you get? 2y dy dx equals minus 2x. dy dx is minus 2x over 2y. So dy dx, that's a y, is equal to minus x over y. All right? Let's keep moving. A little more difficult each time I look at these things. But let's put this one down. That's going to be minus 3x squared dx dx plus, this is the product rule, all right? So I'm going to say x times the derivative of y, which is 1, dy dx. I'm going to put y prime down for that. Plus the derivative of x, which is 1 times y, dx dx, plus 2y, the derivative of y with respect to x, equal derivative of 1 is 0. So I'm going to concentrate on the y prime terms, these things over here, sorry about that, and take these guys and bring them to the other side. Let's do that one step at a time. So y prime, it would be x plus 2y, I just took care of these two, equals 3x squared minus y. What I'm going to do, solve for y prime. What is it? 3x squared minus y over x plus 2y. Y prime is dy dx, by the way. All right? These are a little more complicated. I would recommend at least looking at the key to make sure you're matching what they said it should be. All right, let's do number 68. And 68, I'll kind of do it as easily as I can. So it can be 4y cubed y prime. That guy's done. Plus 3y squared y prime. That guy's done. Let's do the next guy. Plus 2y y prime. That guy's done. Equals, well, the other side's pretty easy, by the way. What do you get? 6x5 dx dx plus 4x cubed dx dx plus 2x dx dx. I'm going to factor out y prime. And what do you get? 4y cubed plus 3y squared plus 2y equals 6x5 plus 4x cubed plus 2x. Let's write this down now. Y prime, I'm going to divide both sides by the coefficient of y prime, which is 4y cubed plus 3y squared plus 2y. Oh, you know what? I just noticed that. And I want to go back over it because I just noticed it now, and I want to go back over. I did make a mistake. I want to correct it. How do you correct things? You go back over them and correct them. All right, so let's write this down. So it's going to be 4y cubed y prime plus 3y squared y prime plus 2y y prime plus the derivative of y, which is just simply y prime. What does that equal? 6x5 plus 4x cubed plus 2x. All right? Factor out y prime. What do you get? 4y cubed plus 3y squared plus 2y plus 1 equals 6x5 plus 4x cubed plus 2x. I want to solve for y prime now, and I'll do that by dividing both sides by y prime's coefficient, which is 4y cubed plus 3y squared plus 2y plus 1. And the right-hand side is 6x5 plus 4x cubed plus 2x. Get the red pen out, see how we did. dy dx is the same thing as y prime, at least in this case. 6x5, 4x cubed plus 2x, 4y cubed plus 3y squared plus 2y plus 1. We did okay. Let's do this one over here, and I'm going to, one step at a time, so to speak. So it's sorry about that. It's actually cosine of x times cosine of y is equal to x. Well, yeah, I got some problems over here. The thing is, I got to differentiate a product. So let's take a look at it. I'll say the first function times the derivative of the second function, which is minus sine. You go the inside derivative of y is going to be what? 1, so I'm just going to put down y prime. Plus, now it's going to be the derivative of the first function, which is minus sine x. Now, if you want the inside derivative of x is 1, dx dx, which I'm not going to write down. Cosine y. The derivative of x is 1. So I think I'm almost there. Let me write this down. Minus cosine x sine y, y prime, which I'll say is dy dx now, is equal to 1 plus sine x cosine y. All right, what I'm going to do now, divide both sides by the derivatives um, coefficient, which is minus cosine x sine y. What goes on top? 1 plus sine x cosine y. Got to clean that up though. So dy dx is equal minus, this is cosine x sine y, 1 plus sine x cosine y. Let's look at the k and see how we did. Dy dx, got the minus sine y cosine x, I did that, and then 1 plus sine x cosine y. Things are looking good. All right, let's do number 70. They do have one step at a time, right? So it's going to be the cosine of y, y prime, minus, that's going to be a tough one, 2xy, just differentiated x by the way, minus x squared y prime. The derivative of tangent secant squared of x, dx, but I'm not going to write that down, equals, that's 12x squared. All right? So I'm going to say cosine y, I see that, and I see this, minus x squared y prime equals 12x squared plus 2xy, that's this guy over here, minus secant squared. Well, what's y prime going to be? 12x squared plus 2xy minus secant squared. And I'm bottoming at cosine of y minus x squared. Let's see what they wrote down. And they write the same thing down. So, the dy dx is y prime. I got the 12x squared, 2xy, minus secant squared, cosine y, minus x squared. You notice I'm not even looking at the work, by the way. I'm kind of looking at the answer, and I think that's probably a good way to go. If you're not getting the answer, though, it's probably in your interest to look at the work. Really is. All right? So let's put this one down now, 71. And let's write it down one step at a time. So e to the y, that's derivative, e to the y. Then the derivative of y is 1, so it's going to be y prime minus 1 over y prime, equals e to the x minus 1 over x. And again, it's dx dx. And I'll write that down. Y prime comes out, and we're left off with e to the y minus 1 over y. E to the x minus 1 over x. Oh boy, what do you do now? Y prime, e to the x minus 1 over x, and the bottom would be e to the y minus 1 over y. I can multiply top and bottom by xy, and the reason for that, I just don't like the way this looks. So what would you get? Y prime would be xy e to the x minus y. On the bottom you get xy e to the x minus x. Can commit to this answer. Look at the answer key, see how we did. Again, dy dx, we're doing okay there. Xy e to the x minus y, xy e to the y. Whoops, mistake is done there, isn't there? So I guess I got sloppy, didn't I? Let's get that eraser out. And I want to point out, I do see it, but I wrote the wrong thing down. So this was not an x, it was a y. And I do see that in my work. It was a copy error. Get this thing out. I'm going to check it. Gotta be more careful next time. And minus x. We're doing okay. All right, let's go to the next question. And again, next question, I hate these things with all these things going on here, but I got to read it. And, f prime is 0. All right, let me just write down what f of x is. Oh, I see it right now. This is f of x right here. So what I'd like to do is write down f prime before I do f prime is 0. So big F of prime would be what? I'm going to say f of x times g prime of x. Let's see. I'm using the product rule, right? So plus f prime of x times g of x. So f prime of 0 is going to be f of 0 times g prime of 0 plus f prime of 0 times g of 0. All right, let's see if I can do that. So f prime of 0, what's f of 0? I got to look at that. So f of 0 is just 3. I'm looking at the table, by the way. What's g prime of 0? I'm going to look at that. G prime, let me point out what I mean by that. You know, g prime of 0 is minus 3. Get the eraser out, I need that. Okay, plus, and again, f prime of 0. F prime of 0 is minus 1. G of 0, 2. What do you get here? Minus 9, minus 2, which is minus 11. All right? So let's do the next one. And I think, for the most part, I need to know what f prime is. This is going to be the quotient rule, and that's going to be g of x squared. And then you're going to get, let's take a look at that. You can get g of x times f prime of x minus f of x times g prime of x. So I'm going to write down f prime at 3. And I want to do one thing at a time, but I still have to look at the table. I can't remember those numbers. I hope you don't think it's important to remember those numbers. You're going to look it up. And I got to do g of 3. And g of 3 is 2. And 2 squared is 4. Okay, I got to go to the top now. And I got to do g of 3. And g of 3 is 2. Times f prime of 3. Well, f prime of 3 is going to be 4. I'm just looking at the table to do that. Minus, what's f of 3? Well, f of 3 is 7. Times g prime of 3. What's g prime of 3? It's 3. Let's see if we can do that. I get a 4 in the bottom. I get 8 minus 21. And that's going to be 13 minus 13 quarters. All right, let's see what happens. Wow, we got it right. Minus 13 quarters. Let's keep going. And this one's a composition here. So let's write this over here. So f prime of x is going to be little f prime of g of x times g prime of x. They want to know f prime at 2, though. It was more complicated. So f prime g of 2 times g prime of 2. Well, I got to concentrate now. F prime. Do I know what g of 2 is? I'll go back up here. And g of 2 is 0. Do I know g prime at 2? And that's going to be the number 5. The next question I answer is, do I know what f prime of 0 is? Go back up to the table. F prime of 0 is minus 1. And that gives me minus 5. All right? Let's keep moving. And again, I keep looking back at that table, by the way, but this is going to be f prime of x. It's a quotient. And it's going to be f of x squared, f of x times g prime of x minus g of x times f prime of x. Again, it's tedious, but let's take a look at this thing. And we need the f prime of 3, right? So do I know what f of 3 is? Let's go back up here. F of 3 is 7. So this is going to be 7 squared. All right? F of 3 is 7. I just did that. What's g prime of 3? Well, g prime of 3 is going to be 3. I'm just looking at the table to get that. What's g of 3? I'm sorry, it's a minus sign. What's g of 3? G of 3 is 2. I'll put that down for you. Okay, what's f prime of 3? Now look up here. F prime of 3 is going to be 4. 7 times 3 is 21. 2 times 4 is 8. 7 squared is 49. Let's see, 49 in the bottom, that's not bad. 21 minus 8 is going to be 13. 13 over 49. Let's do this one over here, and I got to write down f prime of x. That's going to be 5 f of x to the 4th power times f prime of x. Again, it's problematic, and I got to figure out what they want. They want f prime as 0. And so what's f of 0? I don't know, I look it up, I'm not remembering anything. F of 0 is 3. What's f prime of 0? F prime of 0 is minus 1. Well, you get 5. 3 to the 4th power. 3 times 3 is 9, 27, 81. And then you get minus 1. Well, it's going to be minus, and, 5 times 80 is 400, and 5 times 1 is 5, so 405. All right, let's do 77. And what's that going to be? It's going to be f prime. That's going to be f prime of 7x times, to the inside, which is going to be 7, where they want f prime at 0. So it's going to be f prime, well, 7 times 0 is just 0 times 7. Do I know f prime is 0? I don't know. Let's take a look. So f prime of 0 is minus 1. Now scrolling, isn't it? Minus 1 times 7 is going to be minus 7. All right, let's do this one over here. And this big G is going to be, it's a product rule, isn't it? So I'm going to say x cubed times g prime plus 3x squared times g. And where they want g prime at 2. Well, 2 cubed is 8. G prime of 2, I got to look it up. G prime of 2 is 0. There's an awful lot of scrolling. Plus 3 times 4, because 2 squared is 4. And what's g of 2? I have no idea. I'm going to look it up. And g of 2 is also 0. Did I make a mistake somewhere? Look at that, because I wasn't expecting that. G prime of 2. Let me see if I put that down right. G prime of 2. I'm sorry, I made a mistake. It's 5. And I got to correct myself. I wasn't expecting to get 0, 0. That's why I said that. Let me go back up here and erase some things, all right? I made a mistake I wasn't expecting. Let's go back over that. So 2 cubed is 8. G prime of 2. I made a mistake looking at the table, by the way. G prime of 2 is 5. Plus, well, it's going to be 3 times, well, 2 squared is 4. And g of 2, now make careful, all right? G of 2. G of 2 is 0. There's a lot of scrolling here, wasn't there? That's going to be 40 plus 0, which is 40. All right? Going along pretty good. Let's keep going. And, wow. Let's write this down. So I'm going to say h of x is equal to f of x raised to the power of minus 1. So h prime is going to be minus 1 times f of x to the minus 2 times root of the inside, which is f prime of x, where they want h prime at 2, minus 1, minus 2. Now I want to do f of 2. Again, I can't remember. It doesn't. I really mean that. I'm not looking at that. I'm trying to remember what they said. F of 2 is 1. Okay, times f prime at 2. So f prime at 2 is minus 1. Well, isn't that convenient? What do you get over there? You get 1. Okay? So what I'm going to do is I'm going to put a line here, and I'll come back and finish them up. Thank you.